Okay. Welcome to this series of statistical analysis where we explain different step-by-step guide to calculating different statistical tests. Today we will talk about the independent t-test. The independent t-test. I want you to note that the data we are using and some of the materials we're using here we obtained from the book titled Learning to Use Statistical Tests in Psychology by Judith Green and Manuela de Oliveira. So let's go straight. Give you the step-by-step guide. Introduction to independent t-tests. Independent t-test is also known as the t-test related. Uh, Compares the means of two independent groups so as to determine if there is a significant difference in means, in the whether there is a significant mean difference. So it is used when participants are in separate groups. That means when there is no overlap, when the participants that are involved in the different conditions of the experiment are different. Those who are involved in condition A or the experimental group are different from those who are involved in the control group or in condition B of the experiment. So that is when you think about using the independent t-test. The independent t-test involves and must utilize parametric data, that is data that are interval or scale data. And it is based on comparing sample means. So you have to obtain the means to be able to make an adequate comparison. So when to use the independent t-test? Use the independent t-test to compare means of two independent groups. And the data must be interval or ratio, like I mentioned before. Then the research question must involve testing for differences between two groups. And then you must take note of the assumptions. The data must be normally distributed, must be normal distribution, independent samples. Different participants will be involved in different uh, aspects of the test. That means you will obtain data from the data you obtain from the data A, set of data A must be obtained from a different set of individuals from that of set of data B. Then there must be homogeneity of variance. The assumptions for the independent t-test: normality, data should be approximately normally distributed for both groups. Then the independent data points must be independent of each other. And then the homogeneity of variance. This is similar. This is a more concise way of what I just explained. Then what are the steps in calculating the t-test? There are five major steps. You sum and square the individual scores for each conditions. Then you calculate the means for each group. Then you square the individual scores and calculate the difference between means. Okay, this is a repetition. Then apply the formula to calculate the t-test. Let's go down one step and then we'll do this. And you will see what we mean. To do this, let's use this example. Let's say we have a research hypothesis where an experimenter predicted that more words will be recorded from a simple text than from a complex text. So we engage two groups of different participants uh, for each condition. One group was asked to read a simple text, and the other group of different participants were given a complex text. Both groups were given 2 minutes to read the text, and after 10 minutes, they were asked to record the words. The results we presented in table 10.3. So you see the results. These are the condition one, the group condition one, the ones that read the simple text. So the scores X1, they are all stated here. Then condition two, the scores x2, the ones that read the complex test, the scores are stated here. So you see that the table for the t-test independent group is slightly different from that of the PET sample t-test that we have presented before now. You can look up the video to see the difference. Now, you must have to calculate the sum of x1, which is in this case is 64. The sum of x1 is 64 as the case may be. Then the mean is 6.4. So, and then the sum of x2 is 37. The mean for x2, that is mean 2, is 3.7. Then one thing you must do is to calculate the squared scores, which I mentioned before. You square these scores. 10 square, that is 10 times 10, 100. 5 square, 25. 6 square, 36. 3 square, 9. 9 square, 81. 8 square, 64. 7 square, 49. 5 square, 25, and so on and so forth. The same thing too you do with condition 2, or where you square the scores of condition 2. 2 square will give you 4. 1 square will always give you 1. 7 square, 49, and you continue. And then at the end of the day, you sum the square. Summation of x square for x1 square. This is the sum, 450. Summation of x2 square is 165. So this is exactly what you need to apply the formula. So we go to the next step-by-step calculation. The next step-by-step calculation, we have done some of the work previously. So we have summed the total of scores for each condition as seen in table. You see there summation x1 square. We've done that. Then summation x2 square. You can easily get that because we have summation x1 square. You multiply them and summation x2 square. X1 square, you multiply this and then you multiply this. So that's what was done to obtain these results here. Then they calculate the means for each condition. We've done that before now. You can see that the mean for condition 1 and then the mean for condition 2. Then you square the individual scores for each condition. You see the column for the square scores. You see this is column for the squared scores, and then you sum them. You sum it. This is the sum here. The number of participants for each condition. You see that the number of participants for each condition from the table here are 10. If you take a count, you see for each condition there are 10. 10 participants for each condition. Then you apply the formula. The formula is a bit complex, but it's not impossible to do. So you say T equal to minus M1 minus M2 divided by the square root of summation x1 square minus summation x1 all squared divided by n1 plus summation x2 square minus summation x2 all squared divided by n2 all divided by n1 minus 1 plus n2 minus 1. Then multiplied by, bracket here you have 1 over n1 plus 1 over n2. So we know what these symbols mean. So from what we have done before now is stated here. What we have done before now, we know what these symbols mean. So we just put them. So B1 is 6.4, B2 is 3.7. Then we summation x1 square is 450. Then minus summation x1 all squared summation x1 all square. We saw it here that summation x1 all squared, x1 is 64. When you square it, you get 64 times 64, that is 4096. Then divided by 10, n1, then plus summation x2 square. Summation x2 square, that is this score 165. 165. So have it 165 minus summation x2 all squared. That is this score all squared, 37 times 37 will give us 1369 divided by 10. Then all divided by n1 plus 1, which is 10, n1 minus 1, which is 10 minus 1, plus n1 minus n2 minus 1, which is 10 minus 1. And that will give us 9 plus 9, which will give us 18 later. So n over 1 over n1 is 1 over 10 plus 1 over n1, 1 over 10. It will give us 1 divided by 5. And then that will give us 0.2 at the end of the day. So you just do your additions after you must have done this. Take note, you add those in the bracket following the rule, the BODMAS rule. Those in the bracket 450 minus 4096 plus you finish this first and then you do this separately. Whatever result you obtain from each of them, you now add them up. Don't make the mistake of saying 4050 minus 409.6 plus. If you do that, you won't get this answer. You won't get this answer. You have to say 450 minus 409.6. Get the answer, keep it separate, and then do 165 plus minus 136.9. Get the answer, then add both of them and then divide by 18. You will get 3.806. This is important. Then you multiply, when you say 1 over 5, 1 divided by 5 will give us 0.2. Then you multiply this 3.806 times 0.2 will give us 0.7612. Then you find the square root. And after finding the square root, you now divide 2.7 by the results you got from finding the square root. Then you will have 3.096. Please take note that this 2.7 above here could be in the negative form. If it is in the negative form, you don't need to be afraid. Just calm down, continue your calculation. Even if your t value is in the negative form, it's not a problem. What it simply means is that the values obtained at time 2 is higher than the value obtained at time 1, and it have implications in the interpretation later. So now you calculate the degree of freedom. To calculate the degree of freedom, the degree of freedom is n1 minus 1 plus n2 minus 1. So n1 minus 1 is 9 plus n2 minus 1 is 9. That will give us 18. So with this, you can check your table. Level of significance for one tail test should be 0.5. If you have not got the method of checking this, please go to the PET sample T test. Go to the PET sample T test where you will you'll get a better explanation of how to arrive at that. Then, but it's simple. I will show you here level of significance for one tail test, 0.05. you look at our degree of freedom is 18, and that will give us 1.734. 1.734. So that's our T value, T critical value or our T table value. So this table value is important. Now, the critical value, this is exactly how we got the degree of freedom, N1 minus 1 plus N2 minus 1. So use the T distribution table to look up the critical value, which we just did. Then for degree of freedom 8, critical value at T less than 0.05, that is one tail was, we saw it here, 1.734. And this is less than our T calculated value, which is 3.096. So we follow the decision rule. It's important to follow the decision rule. If the calculated T value is greater than the critical T value, the difference between the calculated T value is that value we calculated at this point. This is the calculated T value, 3.096. And then the critical T value is the value we obtained from the table when we said 0.05, and then we married it with 18 here, degree of freedom 18, 1.3734. So this is our critical T value. So if the calculated T value is greater than the critical T value, reject the null hypothesis. So our calculated T value is actually greater than the critical T value. Our calculated T value is 3.096, is greater than 1.734. So we reject the null hypothesis and state that there is a significant mean difference between condition 1 and condition 2. However, if the calculated T value is smaller than the critical value, you will fail to reject the null hypothesis. This is the normal decision rule. So, but in our case here, the first decision applied to us. So we take that. So in summary, in conclusion, the independent t-test compares means between two independent groups. It follows the step. You have to follow the steps that we did now, and to be able to obtain the t value. And then you look up the critical value from the degrees of using the degree of freedom from the table. And after calculating, you go to the table and then you now interpret your this. Like we found out that there is a significant difference because our calculated T is greater than our critical T. So if you see, go back to the table here, you see that our mean 6.4 is well above 3.7 for condition 2. So we can conclude that condition 2 is significantly, the mean is significantly higher than condition 1 mean is significantly higher than condition 2 mean. So what this simply means is that reading simple text improves recall compared to reading complex text. So I have a little assignment here for you, a take-home assignment. Is a take-home assignment which I would like you to follow it. Then a group of psychologists want to investigate the effect of two different types of therapy: CBT, cognitive behavioral therapy, versus mindfulness mediation, on stress reduction. Stress reduction is our dependent variable in this case now. So we are checking therapy type against stress reduction. The participants were randomly assigned to either the CBT group or the mindfulness group, and their stress levels were measured before and after the therapy using a standardized stress scale. The stress scale scores range from 0 to 100, where higher scores indicate more stress. And the following are the post-therapy stress scores. These are the post-therapy stress scores. In this case now, we didn't get the before test or scores, but these are the post-therapy stress scores. So we can use it, they are independent. We can use it to, we can use t-test, independent t-test to analyze it. So you perform an independent t-test, that is unrelated t-test, to determine if there is a statistically significant difference in stress reduction between the two therapy groups. Make sure you use one tail, alpha at 0.05 for significant level at 0.05, and do your analysis and then make your conclusion. You can reach out to me for us to uh, discuss this if you have issues. So thank you for watching. I will encourage you, please, please subscribe to the channel and then like this video. Subscribe to the channel and like this video so that we can have better and more examples to rely on. So thank you for watching and have a lovely day ahead.